The question is related to electricity and magnetism. Topic 4.2 to topic 4.4, mainly about electrical circuits. In the question, a battery is made up of 8 cells. So we have 8 cells which are connected in series. Means, and each cell has an EMF of 1.5. So this is 1, 2, 3, 4, 5, 6, 7, and 8. And each cell is having EMF of 1.5. What will be the EMF of the battery? Battery means combination of the cells. When cells are combined with each other, we call a battery. Like if I have two or more cells, I will call that as a battery. What will be the EMF of the battery? If each cell is 1.5 and there are 8 cells. Yes. How will work out? Good. Because each cell is 1.5 and how many cells are there? 8. So 1.5 multiplied by 8. So what we will get? We will get 12V. So means that total voltage, the total EMF, electromotive force of this supply is 12V. Calculate the energy transfer from a battery in 40 minutes. Whenever there are different formulas to find the energy. Energy is power. The basic formula is energy is power multiplied by time. Okay. So E equals P multiplied by T. How to work out the power? Power is having three different formulas. What are the formulas of the power? P equals VI, that is one of the formula. P equals V square
P
over R,
is
that's
equal
the second
to V
formula.
square over R.
P is equals to I square R, that's the third formula. So we have three different formulas of the power. So I need power. Which formula? I have the resistance, I have the time, and I have the EMF. How to work out the power first? Which formula? First, second, or third? Which formula of the power is applicable here? So the second formula is applicable. The second formula is V square over R. So I will take the total because the battery is there. So it will be 12 square divided by R. How much is the resistance? 8. What about the time? The time is in minutes. The time is in minutes. I have to convert into seconds. SI unit of the time is second. So 40 minutes. What I should do minutes to convert to second? So I will multiply it by 60. So what's the answer? 12 square times 40 times 60 divided by 8. What's 200 and the unit will be joules. Look, this question is of 4 marks. So whenever you see a question of 4 marks, this indicates that you have to use two different formulas. Like we need energy. Energy is power multiplied by time. But to work out the power, we have to use another formula. So whenever a question in physics, whenever a question involves use of two different formulas in the same question, it's always of 4 marks.
Couldn't understand the question or solve it. The question is asking me to find energy. I know the equation of energy.
Yeah, if you write a formula, look, whenever you write a formula, you score 1 mark. So it's important that you write a formula for power, then the substitution is there. You will power. No. Only one. No, we use only one formula here. We use energy is power multiplied by time, but for power, we need voltage square over R and the time is T. So using this formula is 1 mark. Using this formula is 1 mark. Substituting the time from minutes to second is 1 mark. And then final answer is of 1 mark. That's how the marks are distributed. Yeah, and it is obvious if you are able to write a formula, definitely you should be able to substitute. But always write a formula, okay? Describe the energy change that take place during a 40 minutes. What is the energy change in a battery in 40 minutes in the circuit? So the battery is having chemical energy change to electrical. When charges pass through the heater, the charges passes through the resistor. What it will produce? Heat energy. So as you can see the distribution of the marks here. So chemical energy first changes to electrical energy in a battery, and the electrical energy turn into a heat energy in the resistor, because resistor provide heat energy. This question we have discussed in the session as well. Yeah, we did this before. It's like the mover cable has a thick wire appropriate for the current for mover and the correct for fuse. This cable is too short, so the gardener uses an extension with a thin wires intended for use with a reading lamp, like with a low voltage or a current supply. The cable has no fuse. Discuss any dangers of electrical arrangement. What are the dangers of electrical arrangement here? Yes. What are the dangers of electrical arrangement in this figure? Can you identify? Yeah, so cut in the insulation on a damp grass, so he may get an electric shock. That's one thing. Extension cable with very thin wires and no fuse is there in the extension cable. Yeah. Like the extension and the socket is only designed for indoor use. What else? Yeah, so longer length means it will have a high resistance, so it will produce more heat energy. Greater amount of energy will be wasted. Yeah, moist grass will. So the points here, the scoring points, see, different are there. Mention, like example, mentioning of a overheating or a fire seen anywhere. Like you can mention that there might be a overheating or a fire may start, or mentioning electric shock or electrocution seen anywhere, like according to the point. So fire or overheating, if the thin cable or extension cables carry too large current, that will produce heat energy, it may start, or a fire or overheating due to extension cable coiled, so the heat cannot escape. Like when it is coiled, the heat energy one layer is over the other layer, so heat energy cannot escape. But electric shock of gardener, if unsuitable socket lets the moisture and get wet, and electric shock if the tape of a repair lets moist or get wet, and electric shock if the cable is cut by a mover and no circuit breaker is there. Okay, so this you have to relate. Electromagnetic effects. Electromagnetic effect means whenever a current passes through a wire, like electromagnetic effects, changing magnetic field induces EMF. That is the electromagnetic effect. So figure 10.1 shows a wire AB which is suspended on two supports so that it is being between the poles of a strong magnet. The wire is loosely held and it is free to move. Describe and explain any movement of the wire when there is a large direct current in the wire direction A to B. First, we have a current from A to B. So if there's a current in the wire from A to B, what we can do, how we can find the direction of the force, because we want to identify that which direction it will move. So we need the direction of the force. So how we can work out the direction of the force? So to work out the direction of the force, what we will use? We will use the left hand rule. So according to a left hand rule, your index finger point towards south. So my index finger should point to south. South is into the screen, okay? My second finger represents the direction of the current which is moving from A to B. Where thumb is pointing? Where your thumb is pointing when you apply a left hand? So your thumb is pointing upward. So as a result, when the current passes through a wire, the wire will move upward. Got it? And why this wire will move? Because there's an interaction. We will say when a current passes through a wire, the wire produces the current, because there's a magnetic field of a current and there's a magnetic field of a magnet. So when two magnetic fields interact with each other, like if I place two magnets close to each other, they will either attract or repel depending on the poles which are facing. Same thing when two wires are carrying the current, or one wire is carrying a current another in a permanent magnetic field. So as a result, what will happen? There will be a change in the interaction of the magnetic field that will cause a force on the wire. Now, whenever we are finding a force on the wire, we use a left hand. Like If we know the current and we need the force, we use left hand. But if the question was what is the direction of induced current, in that case, we'll use a right hand. So describe and explain any movement and it's of 3 marks. So how we get the 3 marks? So first thing, explanation is there because we have to describe and explain any movement. So when a current passes through a wire, it produces magnetic field which inside of no full. When current passes, EMF you can say a certain terminology like potential difference you can say PD. So when current passes through a wire, it produces magnetic field which cuts the magnetic field of magnet and experience force upward. Now, the second part, a large alternating current. What is the meaning of the term alternating current? It means alternating current, the current will continuously change its direction. First, the current will move from A to B, then the current will move from B to A. So when it was moved, the current is from A to B. What was the direction of the force? It was upward. But when the current is from B to A, what will the direction of the force? Down. So as a result, as the direction of the current will change, the direction of the force will also change. And instead of wire experience either an upward or a downward force, it start to oscillate, vibrate. Because this is what happened in a cone of a loudspeaker, that you're using a speaker. So the cone of a loudspeaker contain a very fine wires in the membrane. So when we pass a current, an alternating current is passed, that current produces a magnetic field which interact the magnetic field of a permanent magnet, and that causes a vibration of the cone. So same thing happened. This even vibration of the wire may produce a sound. It will produce a sound, but we can only hear from 20 hertz to 20,000 hertz. So it might vibrate, but we may not be able to hear it because the audible, it may not be in the audible frequency range, or the amplitude of a vibration might be very low. So the second part, if we are passing a large AC current, so what will happen? The wire will oscillate up and down due to continuous change in direction of the force on the wire. Okay. Is it clear, this one? So these are some questions. As I mentioned, every session we'll discuss some